I'm going to tell you about our journey from Elasticsearch to ClickHouse open source to ClickHouse Cloud. So I'm a lead developer at Lansweeper, and my team is in charge of providing our users tools to analyze data. And what data are we analyzing? So what's Lansweeper? As I copy-paste from our fancy webpage, Lansweeper is an all-in-one solution for discovering, managing, and optimizing IT, OT, and IoT data, which is whatever our clients have in their network. So basically, our product consists of a scanner, which is a desktop application that is installed inside our client's network. This scanner will start to scan everything: assets, cloud resources, OT assets, and then it will push all this information to our cloud. No? So this is the asset discovery capability, asset inventory, and after that, we have assets analytics, which is how we are going to display this information to our users. And it started very simple, really. This is 5 years ago. We were only capable of displaying a table with nothing. Maybe we were able to sort columns. We were able to do very simple search. And everything is stored in MongoDB. So it's not the best solution for real-time analytics, no? So what we wanted at that point, we wanted to display to our users not only assets, but also users, softwares, and vulnerabilities. Those are the entities with a huge cardinality. We also want to let the users customize their views. We want to allow them to filter by any single thing on the table. And we also want them to filter with complex rules, no? So they can get the insights they want. And everything in real time, which means not only real-time queries, but also whatever anything changes in the scanner, it should be reflected to the cloud immediately, in a few seconds, not immediately. So the complexity. Assets are stored in Mongo. Assets have an average of almost 3,000 fields, really. And some of those fields are very complex arrays. We are talking, for instance, solvers are arrays with thousands of elements. And we have 120K installations pushing data to our cloud. So we have today 50 million assets, 150 million users, 1.4 billion softwares, and 5.5 billion vulnerabilities. So this is the data we need to analyze. And it's in Mongo, so not good for analytics. So introducing Elasticsearch, this is the first thing we implemented. The main reason was because we were very familiar with it, no? So we started with it, really with OpenSearch, not Elasticsearch. That should be the same, no? Really? Sometimes. We started with 2 clusters, one for the analytic database with 3 nodes that eventually we scaled to 6 nodes, and another cluster for the vulnerabilities engine, no? Because vulnerabilities are not detected in on-prem. Vulnerabilities are enriched in the cloud. And this is the size of the indexes we had in February 2023 when we did the switch. So we had a bit more than 100 million vulnerabilities, 341 million softwares, and 16 million assets. So it wasn't a lot for that time. And this is also not a lot for ClickHouse, for Elasticsearch. So this is more or less our architecture, our data pipeline. So when our installations publish the information to the cloud, everything is pushed into Kafka. And now we have a consumer service that takes this information from Kafka and stores it in MongoDB. We are not replacing MongoDB. MongoDB is, in fact, our single source of truth. And then we have a series of enriching services that takes this data, enrich it, like adding vulnerabilities, and then we store this information in Elasticsearch. And then we have our API layer that exposes this information to our client. No? So our consumers are built in Node.js, and the API is also Node with GraphQL. So we did it. Now we have analytic capabilities, we have customizable views, we have advanced filters, we have full text search because we have Elasticsearch, and export capabilities. And most important thing, we have aggregated views. This is really, really important because when you see a list of softwares and you have 1 million softwares in your network, you don't want to see a list of 1 million elements. You want to see the name of the softwares and how many assets have this software installed. No? This is an aggregated view, the same for vulnerabilities and for softwares. So, what went wrong? I feel a bit intimidated because there is people here that work for Elasticsearch. So I hope I don't say anything wrong. I'm not going into detail. So the first reason we switched from Elasticsearch was because it was very expensive. 17% of the total cost of our cloud platform was only for Elasticsearch. And we even tried to see for alternatives with the official Elastic Cloud, but it was like 2 to 3 times more expensive for the same hardware. We also have some problems and limitations about the data ingestion. This is because our assets are really, really big. Changes are really, really frequent. And let's say we didn't have enough time now to optimize our data pipeline not to support this kind of volume of data. But I mean, you can pay more and you can scale, so that's not a problem. And last thing, well, there was like a complexity between OpenSearch and Elasticsearch. There was a moment where Elasticsearch changed the license, the drivers were different, so something we weren't really comfortable with. And finally, we found a lot of limitations for the vulnerabilities page because we wanted to explore vulnerabilities from different points of view, not only from the SAVE, but also from the asset point. And this requires creating new indexes and, well, something we couldn't manage to solve. So we started looking for alternatives, and we found the first one, of course, ClickHouse. We needed an OLAP database. And we did some performance testings against OpenSearch. And we found not only that ClickHouse outperformed Elastic in every single test, but sometimes it was 10 times faster with a slower hardware, because we were testing the production hardware for Elastic against our laptop with ClickHouse. And of course, this allowed us to build the missing functionalities we wanted for vulnerabilities. So initially, we created a ClickHouse cluster in our AKS infrastructure using the Kubernetes operator created by Altinity. The initial architecture was with 3 replica clusters with very fast SSDs and Zookeeper. Let's talk about that. And well, the migration was quite smooth. As you can see, the architecture is mostly the same. Notice we changed node services by Golang services. Great decision. We found that for Kafka consumers, Go is a great fit. But yeah, it's the same enriching process. We take the information from Kafka, we put it on ClickHouse, and then we retrieve it from our Analytics API. Something very interesting, our Analytics API also have like it doesn't perform query directly to ClickHouse. We have like a JSON model that is very similar to Luzmo model, no? To Luzmo Analytics model. So we are more or less independent from the database. This is how we switch from Elastic to ClickHouse without really modifying our services. One problem we faced with this change was that we wanted real-time updates, and our assets change really, really fast, very, very often, are really, really big. And ClickHouse, at that moment, didn't support really updates. We really want to see how it performs with the new lightweight updates and the new engines replaced shared merge tree table. But at that moment, we couldn't. So how are we supporting real-time updates? We don't. We perform inserts, same thing as Luzmo. We thought we were going to be the first one to do that, but of course not. So we have only one table where we store everything, all the information. The table is, of course, the sorting key is a combination of the client key and the set key. This is something really important when you work with ClickHouse. You need to choose the correct sorting key because this defines really how many rows you are going to read. And also, well, the partition keys by the date we were inserting these files, these documents. So how do we do inserts? We just insert a new row with everything. If the asset has 200 fields, we are taking those 200 fields from MongoDB, and we are putting them in ClickHouse, like that. If you want to delete, we just insert a new row, which is almost empty except for one field that tells the row is deleted. And if you are going to do an update, we just insert a new row with a different registered created key, so we know which is the later one. And then whenever we perform a query, we aggregate by those fields. No? It sounds a little bit overkill, but ClickHouse is really fast doing that. So why not? We have very big clients with almost 1 million assets, and these things work as fast as if we weren't doing the aggregation. So it proves to be really good. What went wrong? Still, because we were using the AWS infrastructure and SSDs are really, really expensive, we didn't like the price of that. And also, scaling horizontally was a bit difficult. This is probably a skill issue because you can horizontally scale ClickHouse on-premise, but it's not the easiest thing. Let's say that. And the main problem, and why we switched, Zookeeper. Why Zookeeper? Out of memories, this corrupted. I don't know why Kubernetes hates the Java virtual machine. Zookeeper won't start. We have in staging an incident where we have 3 nodes in staging. One of the nodes got out of sync, and we never recovered it. So there we go. Out of memory everywhere. Zookeeper is not really good when you have to update a lot of information. It's really good when you have to do a lot of read queries. When you have to write a lot, it's not. If you do this, use ClickHouse Keeper. So we don't want to maintain ClickHouse infrastructure. So what do we do? ClickHouse Cloud. At the same time we were releasing that, ClickHouse Cloud was open to everyone. So it was our first early adopting experience, and it was quite good, to be honest. We didn't do anything, like no rework, no downtime. We just changed the connection credentials. Of course, because our architecture used Kafka consumers, we had to create a new consumer and a new database and migrate the data. But from our client's perspective, nothing changed. And the performance was almost the same. It's true that because we are using S3, there is sometimes a little bit of delay with the first query, but it's almost not noticed by it can be noticed by your client. So we can say the performance is the same with less hardware than the on-prem. So we knew that ClickHouse Cloud was going to be a lot cheaper than the on-prem because of S3. We are not longer paying those really expensive SSDs. But that's interesting. With the current data we have right now, we are paying 30% of the cost of OpenSearch with 3 times more assets. Because right now, we move from 17 million to 50 million assets today. And even the cost of ClickHouse Cloud, with all the new features we are implemented, with new clusters, it's still 50% of the cost of we were paying 3 years ago with OpenSearch. So this is just a metric so you know more or less the usage we have with ClickHouse Cloud. We are inserting right now 17 terabytes per week of information in one single table. And the number of inserts, this is really important, is more or less 1 insert per second. This is because, because of the way ClickHouse needs to merge the partition. It's really important to do as less updates as possible. So we keep that number in one per second. And even if we are inserting 17 terabytes of data, as you can see, the disk usage is almost linear. It never gets more than 1 terabyte. This is because all the duplicates we are inserting are automatically deleted by ClickHouse because we are using the replace image engine tree. So, what's next? Well, as always, speed and efficiency is not everything. Our customers still feels that they are constrained exploring the data. And one thing they do a lot is they are exporting the information to analyze it in other tools, like for instance Power BI. 5 years ago, when we had the mentality of Lansweeper is only an inventory tool, that was fine. But now that we have ClickHouse, we can offer more things. So we need more. We need each customer to have their unique data insights. We want to provide our clients a tool to create their own dashboards, and we want the new tool to integrate correctly with our UI. Of course, our UX team is really concerned about the UI. It needs to be consistent, so the tool must fit in our design language. So, Luzmo. this is, whoop, where is it? OK. So this is how our inventory table looks like. As I said, it's pretty basic, just a table. You can do some things. You can customize the view. You can remove and add columns. You can create filters. Things like, I don't know, type equal to Windows, for instance. No? And then you can create nested filters with more advanced conditions. You can search globally. You can save the view. So you can do a lot of things, but this is not really insights, no? That's just pre-configured views you can have. And also, very important, we have the inventory in one page. The risk insights, which are the vulnerabilities, are in another page. Reports, users is in another page. So it's very difficult to combine the data just with tables. So this is our new experience. In fact, like 2 hours ago, we had the release for our public. So this is how it looks like right now. And it's incredibly powerful because instead of having to worry about the filters, about the configuration, you can just add a bunch of widgets. And for instance, this is a view that mixes assets and software. If you want to see, for instance, assets that, in this case, the disk usage is between 60 or 70%, I can just click here, and the whole dashboard is updated. Or I can filter by the asset type, by Windows or Linux. And then I can drill down, can continue filtering. So now these are insights, no? We let the client to create their own insights. Things like vulnerabilities, for example. We can filter by the severity of the vulnerability. Then we can drill down to know the ones that are their patch info is available, and then we can go for the ones that the confidentiality is high. So you can keep going and create your own reports. And of course, we have very nice and fancy visualizations. Like this thing, no? I don't know if you have worked with charting libraries, but you really don't want to do this yourself. Normally, you want to introduce this as a new service. So, yeah, that's it.